4.2. Well, at least Tate, you are now the go-to person on 4.2. That's awesome.
Yeah.
Proud of you.
You so much to me.
So
I didn't think we finished it, so.
no, we were up through like 29. We can take a quick look, page 263, just to look at it. We're not going to do necessarily like 31. It says bound on 31 and 32. They have the graph. Bound the area of the shaded region by approximating upper and lower sums using rectangles of width 1. So again, that's actually just, you're just looking at a visual on the graph, and then you would, on those ones, you would simply look at making, like on 31 there, you would, because it says by approximately the upper and lower sums. So the upper sum would be where you have an overage, the lower sum would be where you have an underage. So if the graph, like on that one, on 31, it's like this, right? And you want to find this area, but if you're only using rectangles, they would say, they tell you that the width is 1. So you'd look, okay, I'm going over 1, the overage, so the upper sum would be, you'd have to go all the way to the top there and then bring it over, even though that's excessive. Yeah. And then you'd say, what's the area of this one? What's the area of this one? And just find the area of those. Yeah. Then the underage would be, for the smaller one, would be if you're looking at, because it doesn't start there, I'm sorry, it goes like this, right? So then the underage width of 1, it would be going here and over, finding that area. So that's all they're having you do on 31. When you look at 33, 35, and you use the upper and lower sums to approximate the area of the region using a given number of subintervals. So same thing, just finding the areas of the rectangles with that. So not a whole lot of any difference in there with those ones. Okay, now when we jump up to 37, 39, 41, that takes us back to the limits with this. So find a formula for the sum of n terms. Use the formula to find the limit as n approaches infinity. So if we take a look at 37, this is where I don't know, I'm sorry Tate, you already did the work, but we may not do all of these. So if we take a look at 37, okay, let's just, this is one of your homework ones, but we'll do it together. This is the limit as n approaches infinity, and you have n, and then I equals 1, and then 24i over n squared, right? Okay. So what they're looking for you to do is not, they're not looking for you, because you can't plug that into your calculator. Well, you may be able to, I don't know. But since it says n goes to infinity, it's not on your calculator. If this was the number 10, you could just plug this whole thing in, right? It would be 24i over 10 squared, and you just, plugging that in your calculator, hit enter. What they're asking for is as n goes to infinity, what's the sum? Now, with that being said, what they're looking for you to do is to take this, which we kind of already did one of these, and they want you to go like the limit as n approaches infinity, mess around with this till we can get this formula into one of our sum or our formulas, right, from the book, from page 3, whatever, or 260, 55, or whatever it is, whatever those formulas are. 250.
So it'd be like 1 over
That would be on
n squared, sigma.
Man, where was that? Was that
equals 1.
on page 255.
Yeah, 255. Okay. Yeah, so Nick, can you pull out the 1 over n squared?
Yeah.
Okay. So we can pull out the 1 over n squared, and then actually we can pull out the 24, right? So 24 over n squared, and you're left with I equals 1, n, and then just the I, right? Is that all we're left with?
Yeah.
Yeah, just left with the I.
And then
And then what isn't that one of our formulas?
yeah.
which would be going over to, like Tate told us, instruct us.
Times n plus 1 plus 2. And then you just put it in. You get 12.
And then now, like when you look at this, that's just a limit. Like, hey, find the limit of that. Now we're out of sigma notation,
Yeah.
and now it's just finding the limit. And you say, okay, you know, that you already stated was 12, right?
So it would
And
just
then,
be 12 plus 12 over n squared. So it'd just be 12.
and then,
Yeah.
yeah, this, because n squared would go into both of these, right?
Yeah.
And then that one would go to
12
0.
over n.
This would be just 12.
The 12 is the n squared.
Yeah. Okay, so try that on, give an attempt, not that they're extreme, but give an attempt on 39 and 41. CalChat can help you, but that's what your goal is, to take this, turn it into something, one of our formulas, reduce it, and then go from there.
Like on the quiz or test, we're not gonna, unless you give us the.
I'll give you the formulas, right? I'll give you the formulas, and maybe you have one like this, and you just show your work, and then go.
So it's not like we have to memorize the formulas and then.
No, don't memorize the formulas from page 255. I'll give you those.
Okay.
So do not memorize the formulas. Okay, then, so that takes care of those ones. Then we have let's skip 43. So skip 43, not that it's not useful, but I don't want to focus on it. So we got to get through this. And then let's go up to your 45 through 53 ones and take a look at those. So 45 through 53, it says use the limit process to find the area of the region bounded by the graph of the function of the x-axis over the given interval. So now on this, what they're referring to is the limit process. Let's go ahead and do 46. We'll do 46, which would be like 45. We'll do a couple of these. So y equals 3x minus 2, right? And then it's on the interval 2 to 5, right? And then graph this, 3x minus 2. So we go -2 here, up 3, right 1. And it's from 2 to 5, right? So 2, 2, 3, 4, 5. So they are looking at this interval here to here. Okay. Now, is it obvious? Maybe it's obvious. It should be obvious that with like one like this, you could just do like the area of the trapezoid, right, and find the area, but that's not the purpose, because the purpose is to practice what happens when it's a curve, right? So Tate, since you did the homework, what would be your first step here? I mean, we've graphed it, right? And we understand our area we're looking for is this area, but it wants us to use the limit process to find the area. Let me pause to help you out. Okay, although earlier we did this, right? We said, hey, find this rectangle, this rectangle, this rectangle, done, right? The limit process says, hey, you're not just finding widths of 1, 1, 1. You're now going to be finding widths of infinitely small. So this will take us to the summation of, if you will, something like this. The summation of how many rectangles? Infinite. So that's what we're looking at.
How do we do it without putting in sigma?
Well, we will do it. We'll do it with sigma. If you recall,
like
sigma.
later on, though, how are we gonna do it? Like when we don't use sigma, like we'll still be going to infinity, right?
Yeah,
You
it'll
said
still
we
be
don't
going
use-
into infinity.
Because you said we don't use sigma.
We don't use the sigma notation. We still use the concept of sigma, but not the sigma notation. So here, if you recall, remember how do you find the? We did this back on whatever one of the first days we were doing this, remember we were doing, that example of, we did the, from like I equals 1 to up to 5, because there's 5 rectangles, do you remember that?
Yeah.
And it was, I don't know what the curve was, but
It's like 0.4h equals.
yeah, you know, you had some curve like this, where you're saying, you know, it was split from 2 to 5 or something. 2 to 5, and then he said, okay, it was 2/5, 2/5, 2/5, 2/5, because it like split up. Okay.
Wait,
So-
with 46, I was a straight line, so I just did the width of it, which was 3 times by height 1,
I know, but he's
plus
got-
height 2 divided by 2.
So it wants us to use the limit process, not just finding the area of the trapezoid. So with the limit process, what we're going to do is we're going to say, okay, the summation, right? And we're going to start with the first interval, and then how many intervals are we going to have?
Infinite.
We're going to have an infinite amount of intervals eventually, right? So with this, so we're not going to say, hey, we're not going to say this goes up
And
to.
I equals interval, or it doesn't equal interval.
No, I just equals.
Just the random. Like
And I equals 3, because I equals 2, because that's what it starts at.
Well, it depends. You could have it as I equals 2, but it depends on what your formula is going to be.
Yeah, because it starts at intervals 2, 5. And n is equal to 5, because that's what ends. And it starts at x equals 2. So you put I equals 2.
5 like this.
Yeah, that's the interval.
So, how do you find out the number of rectangles? What was that little formula for the number of rectangles?
It was infinite, so.
What's the delta x? What's delta x? How do you find delta x?
Oh, is that the n times by n plus 1?
What?
Never mind.
How do you find delta x? Oh, it's just like this
It's
one
whatever
here.
over, it's whatever over infinity. Or not infinity. Where is it over?
Well, it will be
Yeah,
infinity
so-
in the end, but what is it?
However many.
It's your interval
Yeah. well,
minus, or not minus, it's your interval, so 5 minus 2 in this case, right? Because we're going from 2 to 5, divided by n. So our
that's the amount-
delta x-
N equals the amount of triangles, correct?
n is equal to the amount of triangles you're going to use.
So
Or
it would be,
rectangles.
so it's,
number of
it
rectangles.
is infinity.
It is infinity.
Eventually.
Yes, it'll be infinitely small.
Yeah.
Well, we're not going to say delta x is 0, because then it isn't 0. Even though as n goes to infinity, it goes to 0. It's not 0. If you just call it 0, then this whole thing would be 0, because it would be the base is 0 times the height. So we do know, remember, when we're doing this is saying I equals 1 up to n, because there's going to be n amount of rectangles.
I'm good.
Then what we know is we have to have remember how we do this, a height, right, times a base, right? And you just told me what the base is. What's the base? 3 over n, okay.
And then you're gonna multiply
Now,
that
the
by-
height of this is, now remember, like Tate was saying, it's I equals 2. There's a couple ways to go about it. If you,
Isn't it just f of x?
you're saying, right, so it's like essentially f of x for the height, but you're not starting at 0. If you say f of 1, you'd be plugging in 1. If you say f of 2,
Well, it would just be f of 2 plus f of 5 divided by 2. That's the answer for the height.
f of 2 plus f of 5 divided by 2.
Yeah,
Um,
that's how you find the area of trapezoid.
But that's not.
we're not dealing with the area of the trapezoid.
That's not.
We are not dealing with the area of the trapezoid. I'm so sorry that you are thinking the area of the trapezoid. We're not. Not dealing with the area of the trapezoid. Okay, so what we're plugging in, if you recall over here with this one, and maybe we should have reviewed this one because it's like day 4 of this lecture, is delta x over here was 5 minus 2 divided by, was it 5, or was it, it wasn't 5 minus 2.
Yeah, 5 minus 2.
What was it on that?
5 minus 2 divided by n.
No. this was from the beginning.
2/5.
Was it, it was 0 to 2.
Yeah, so
That's what it was 0 to 2, whatever, and then so then we said 2 minus 0 over 5, because there's 5 rectangles, delta x is equal to 2/5. So when we plugged it in, we were actually, you were just saying f of, if you recall, 2/5 I, you remember that? As 2/5 I, so that was what we plugged in, because 2/5 I would bring you over to this little portion up to there, this little portion up to there. So the issue here is that it's not, for starters, it's not 2/5 for delta x, it's 3 over n, right?
yeah.
So you could say, if you think about it, let's get it started at 3i over n, okay? So that when you plug in like 1, it's taking for however many rectangles you have, right? So let's say you let n equal 3, whatever. If n is equal to 3, then you're going to have 3 rectangles, 1, 2, and 3. And so you'd have f of, right? If n was 3, you'd have 3 over 3 times I. So really what you'd be just doing is f of I, meaning if I is 1, you're plugging in just over 1 space. The issue though is that this is 3x minus 2. You're starting at where? 2. So if you said, if this was the case, I'm going to have 3 rectangles, right? And therefore it's just f of I. And so what is f of 1, f of 2, and f of 3, right? Because you're only going to do 3 rectangles. Well, the issue is if you plug in f of 1 is not going to actually be on the integral. So what you're really looking for is, you're looking for over 2 plus whatever I is. So you're really starting at
So it's f of 2 plus
f of 2 plus I, in this case, right? Because if you said n was 3. But we're not going to let n be 3, n's going to be infinite. So it's actually f of 2 plus 3i over n. And so this would be f of 2 plus 3i over n. Now it looks a little confusing. Hopefully we understand the 2 plus 3 over n. 2 allows us to, we're plugging in 2 to get over to the start of our interval. So if this was 3 to 5, let's say, then it would be 3 plus 3i over n.
Yeah,
and
it's
then
not that. I just am struggling how you come up with the plus 3i over n.
Okay, 3i over n, we come back over to this example where we did this one, and this was, right, we understood that delta x was 2/5 on this example, right?
Yeah.
And so if we could even, I don't know what was the equation, f of x is equal to, maybe we should have revisited the exact one, so negative x squared plus 5. So that was the original. So if we're going back to this one, should just do it correctly. Negative x squared plus 5, so it's 5, then went down like this. We were going from over 0 over to 2, right?
Yeah.
And so it was like over to 2. So is this area right in here?
Yeah.
And we said we want to use 5 rectangles.
Mm-hmm.
So what we knew is there was going to be 5 rectangles in here. So 1, 2, 3, 4. That's kind of a 4. 1, 2, 3, 4, 5. Well, again,
Yeah.
I think you get the point.
Yeah.
1 rectangle, 2 rectangles, 3 rectangles, 4 rectangles, and then the 5th rectangle, right?
Mm-hmm.
So we understand that the width on all of these is 2/5,
Yes.
right?
Mm-hmm.
That's because we did 2 minus 0 divided by 5 rectangles. We said we
Yeah,
want
we got
5
that.
rectangles,
Uh-huh.
okay? So now when we go to find the area of each rectangle, it's going to be base times the height, right? Now the height is going to be changing, so it's going to be 2/5 times whatever the height is. So to get the height, you would say, well, the first value right here is going to be for the over this, up this. This coordinate point would be 2/5. Oops, not 2 over 5. This coordinate point would be 2/5, comma, f of 2/5, right?
Yeah.
The next coordinate would be 4/5, comma,
F of,
f of 4/5.
yeah.
The other way we could look at that, and then we can keep going, right?
Uh-huh.
6/5, f of 6/5. The other way you could look at that is simply to state that the height is going to be f of 2/5 I.
And where's the I come from?
I just represents on your sigma notation, I equals the first interval, the second interval, the fifth,
Yeah.
and then all the way up to
The
the fifth.
intervals are gonna be increasing infinitely.
Well, right, for this one, it would have been,
Well, yeah, but I'm just trying to like figure out,
Yeah.
cause like I can do this one, but it's once I get to the,
so this one makes sense, right?
Yeah.
2/5, because it's always 2/5. It never changes, it's always 2/5. This is going to be 2/5 I, meaning you plug in 1, so it's, and the reason why it's 2/5 is because it's giving you over 2/5, and then you plug in 2 over 4/5.
oh, so then you're going,
Over-
so on the other one, you're going over 3 over n.
Yep, whatever n is.
Yeah, but n is gonna be infinity.
Yeah, for now you don't have
So
to
where
worry. Yeah.
So why does the I come in?
Well, the I is telling you what is the height. You have to have f of, because it's not always the same.
Oh, you're right.
So this and,
So it's timesing it by that.
so this is going to be your base.
Yeah, I got
Right.
the base plugged in.
That's
It's just
why
like
I can-
figuring out the height.
The height is f of, meaning it's your function of wherever you're at here.
Okay.
So if it, and it's a little hard because we're saying n goes to infinity, so you're like, well, n could be whatever, and that's exactly right. But if n, like over here, n was 5.
Mm-hmm.
So then it's always going to be 2/5 times 1, 2/5 times 2, 2/5 times 3, 2/5 times 4. It's always 2/5 times that. Over here, it's just 3 over n, whatever the interval is, times I. So we're going, when you plug in 1, you go over some amount. When you plug in 2, you go over some amount. 3, you go over some amount. 4, 5, 6, 7, 9, 10.
So technically it could be, we could do the same thing and have f of 3i over n and I equals 2. If we start the interval at 2 right there and we change I equals 2, then we don't have to do f of 2. We can do f of just 3i over n, correct?
3i.
Just, you could erase, if you started at 2, could you erase this one?
I see what you're saying. So instead of saying like I equals 1,
Yeah.
right, which then would be 3 over n
Mm-hmm.
plus 2.
Which would be, so then it would be 0 plus 2, which is 2. Or
Well, you gotta go over
yeah,
2.
yeah, sorry. Yeah.
So this would have to be 3.
Wait, why 3?
Well, because you're going over, if you're gonna erase the 2, you have to compensate for the 2 units over. So instead of starting at 1, to compensate for the 2 units over, you would start at 3.
Okay.
And then get rid of that. And then this would be stating 3, so it'd be like 3 times 3, so 9 over n, f of whatever n is.
So that'd be, wait, so,
Okay, yeah.
you would just,
I see there would be a way to manipulate that so that you could start it instead of saying 2. As the reason why we have 2 plus is to compensate for the fact that we're starting the interval at 2
Yeah.
rather than at 0. Because if we did this, we'd be saying when I equals 1, because remember 3i over n is 3 over n represents the width of each rectangle. And so then if to make and maybe it would be beneficial just to plug in, let's say we said n was, what do you want, 6 rectangles?
Yeah.
So if we had 6 rectangles, it would no longer be 3i over n delta x would be 3 over 6 rectangles, delta x is 1/2, and then f of, so then it would be 3i over 2, 3i over 6, which would be just f of what, 1/2 I, right?
Yeah. But you would start
And then you would say, okay, we plug in 1,
Yeah.
because that's the first interval of, so it would be, 1/2, but when you plug in 1, what you're saying is f of 1/2, which would really be stating, if this is over 2, this is over 1, you're saying f of 1/2 coming down here.
Yeah.
And then when you plug in 2, you're actually saying that's f of 1, which would be there. F of 3 would be 3/2 there. And by the time you get to f of 4,
Yeah.
now you can start there. So I don't know.
Oh, I see what you're saying. Yeah, I see that.
So I don't know, because as we change n, that would change.
Yeah, so don't do like the erase thing, but.
Yeah, that would. But I see what you're saying. But I think if we made n 6, we see that we would have to go over 4 times to start where we want. So this would have to start at 4.
Yeah, but we're not gonna do that.
Or even 5. We'd have to start 5, because 4 would get us to the beginning. We'd have to go 5 and get us over part way up to get our first
But
rectangle.
we're gonna start at 1.
Start at 1 and compensated by it takes us over to 2, and then you plug in 1 and it gives you some width over, and then starts the rectangle.
Yeah.
I have a question.
So, okay, Tate.
Can you look at this formula? I was trying to copy down what you said and make it into a formula, but just by looking at the numbers. Or can I show you?
No, we need to finish this. So, when we do this then, we are going to, this would be finding the area of the rectangles, right? This represents the height times the base. And if you wanted 6 rectangles, you just plug in 6. If you wanted 10, you plug in 10. Then we come over here and we say, okay, this represents some sort of, we're talking about the
So we
same
just get
one.
it out of that.
So we say, what's the limit as n approaches
And then
infinity?
get it out of sigma notation and then do it.
Yeah, so how would we get this one out of sigma notation? Well, we could take out,
Well, wouldn't we just plug in to the, oh no, because that'll introduce another.
well, you can plug in f of, what's our original equation, 3x minus 2, right?
Yeah, so could you just plug in?
So you're going to plug that in to get it out of f of notation. So you're going to have this sigma of I equals 1 up to n. You're plugging in 2 plus 3i over n into there, so it's 3 times 2 plus 3i over n.
Plus 6i over n.
Minus 2, all of that times
3 over n.
3 over n, right?
And then would you just put that in, or?
So we could,
Cause I got 6 plus 6i over n minus
6 plus 9i
Oh yeah, sorry, 9i.
over n minus 2.
Yeah, all times 3n. Or 3 over n.
Then what could I do with the 3 over n?
Bring it out and just get rid of it.
Yeah, bring it out. It doesn't get rid of it, but, alright. And then what's this, 4 plus 9i over n?
No,
Yeah, 9i over n. So then could you take out the 4? Or no, that's when you split the sigmas, right?
You could, I'm thinking, what if you got would it help to get a common denominator? I don't think it would. Yeah, it could. What if we do this? Can we do a common denominator of 4n plus 9i over n? Then we could take the n squared out, right? Or the n out on the bottom.
Yeah.
So then it would be 3 over n squared times sigma I equals 1, 4n plus 9i.
plus 9i. Is that when you have to split sigmas now?
And then, yeah, you could do what is the sigma of 4n. We have a formula for that where n is a constant.
Cn.
Yep, it's just Cn, right?
So it's just. Wait.
Well, 4n, where n is a constant, it's just going to be
What did it be for then? Wait, I'm confused. I'm reading the formula wrong, I think.
yeah, it actually would be 4n squared. Because if you do this, right, I equals 1 of 4n. So if we just separate this out,
Oh yeah, it's 4n squared.
we know n is a constant.
Because usually we wouldn't have the n. Usually we would have just 4, and then
Right.
we would bring it in and get 4n. So now instead we get 4n squared.
Okay, so that's going to be 4n squared plus 9 times,
And that's multiplied.
yeah, so plus 9 times whatever sigma of I is,
Plus 9.
and I is n times n plus 1 over 2, right?
So it's 9n squared plus 9n plus 9n over 2.
9n squared
Plus 9n.
plus 9n all over 2.
And then when you do that in, you get 12 plus 9.
27.
Oh yeah, sorry, 27. It's 27. And then the rest doesn't matter because it goes to infinity. So then you're gonna get an answer of 39. Because the rest of the math is over an n, which means it'll go to infinity. So
That should go to 0, that should go to 0.
Wait, no, because the ends
Well, I mean,
cancel
they're not
out.
go to 0, that
It's
should go
at
to
27.
27.
So then you get 39,
39.
plus goes to infinity, which gives you 39. Which is?
Correct. No. They have 51 over 2. This isn't 27, it's 27 over
Oh.
2, because the n squareds cancel, so good. 27 over 2
Plus 12
plus 12,
is the answer.
24 plus 27, 51 over 2.
Yes! I'm smart. Tate over there just doing his crap.
Just grinding away on the captain. So like on the chapter assessment and test, one of these with practice would be viable. Some of them get a little more intensive, but this would be viable. What this is setting us up for is the understanding basically of, remember how we did limits for finding the derivative, the slope, and remember the long process. So that's what this is, and then essentially you end up with the cheater methods. Cheater method going.
Oh, so it doesn't get harder. Like this is to make it get
This is the most difficult part, is this concept of sigma notation. But I want to teach it, which we're doing, and then we go into cheater method basically.
Okay. So that's what we did with derivatives.
Yeah, and I might have one do sigma notation, finding the area of this.
Yeah.
You know, where it's like with some practice, it should make sense.
Goodbye, Riley.